All right, looking at 7.4, solving polynomial equations in factored form. So we talked about standard form earlier, or well, earlier for me, it might have been days for you. But standard form right here, it is where we have the exponents in order from biggest to smallest. Okay. Factored form is when it's broken apart into pieces that are multiplied together. So if you look up, let's look at example 10 here. This piece right here would be considered factored form, and this down here would be standard form. Okay, so there's a little bit of a difference there. Going back to where we're supposed to be. Let's look right here. When one side of an equation, right, so far we've just been working with expressions, right? An expression doesn't have an equal sign. Now we have an equal sign. When one side of an equation is a polynomial in factored form and the other side is 0, we're going to use the zero product property to solve the polynomial equations. The solutions for an equation are also called roots. Okay, so that's kind of a synonym there. All right, what the zero product property does, zero product property, if we have two numbers A and B, and we multiply them together, and they spit out 0, right? If you take two numbers, you multiply them together, right? Two numbers, any two numbers, and they give 0, you know that one of them or both of them has to be 0, right? If you have 5x equals 0, well, we know that x equals 0, right? If we had x times 6 equals 0, well, we know that x equals 0. If we have a times b equals 0, then we have that a equals 0 or b equals 0. So what we're going to be doing in factored form is we're going to be looking at the pieces being equal to 0, right? If one piece is, then we could also say, well, maybe the other piece is. So let's look down at example 18 here. Right here we have two pieces that are multiplied together, the 3x and then this piece right there. I'm going to split them up using the zero products property, right? They are multiplied together and they got 0. So I'm going to say, well, 3x has to be 0 or x minus 7 has to be 0. On the left, that should be easy to solve and get x equals 0. On the right, that's also pretty easy. We add the 7 and we get x equals 7. All right, that's as difficult as that gets. Later on, they're a little bit more extensive, but really not that crazy. That's it. We take the left side and set them equal to 0, the right side equal to 0, and we're done. Now, we could extend this zero products property further. We could say maybe we have x times a times b, right? 3 pieces. Well, then we just add in an x equals 0 also, okay? So if you have 3 pieces, 4 pieces, 5 pieces, you can always use the zero products property. It works for as many pieces as you want. All right, 19. Again, we have 2 pieces. We have the x minus 8 and the x minus 11. The zero products property tells us that one or both of them has to be 0. So I'll say x minus 8 is 0 and x minus 11 is 0. The left one gives me x equals 8. The right one gives me x equals 11. That's that. Next up, again, we have 2 pieces. We have the left piece and the right piece. I'll say 4x plus 5 is 0, and 4x minus 5 is 0. On the left side, I'll subtract 5, and I get 4x is negative 5. Then I divide by 4, and I get x equals negative 5 over 4. All right, so that's our first fractional answer, but that's okay. We can get fractions as an answer here. On the right, I add the 5 over, and I get 4x equals 5. Dividing by 4, I get x equals 5/4. There we go. Something just patterns that we should see. On the first one, in the yellow piece there, we had an x by himself. That answer gave us a 0. We have a negative 7. That gave us a positive 7. Okay, that's just a pattern. That would be something good to look at. Right here in the yellow, we had a -8, and our answer was a +8. -11, +11. Down here, this one we have something sitting in front of our x, right? We have a coefficient on our x term. On both of these, the 4s, they're the denominators. That's something good to recognize. And then for the blue one, we have a plus, and it gave us a minus. On the orange one, there's a minus, and it gave us a positive at the end. Okay, those are good, good things to recognize. All right, 21. Oh, we have another page too. Look at that. 21. We want to factor this. We want to undo distribute. We want to pull out the biggest numbers that we can. We want to pull out all that we can. Starting off, I like to look at the numbers right here. We have a 5 and a 35. We could divide both those numbers by 5, right? That means we could pull out a 5. And then the x's. One of them has 8, the other one has 6. So I want to pull out as many as I can. I'm going to pull out 6 of them. Now, in this first piece, I pulled out the 5, and I pulled out 6 x's. So that means there's 2 of them left over. So x squared is left over. In the second piece, the minus stays. 35 divided by 5 gives me the 7. And then x to the 6, I removed all 6 of those. So that's it. This is going to be our answer. And to check ourselves, you can always distribute this back in using polynomial multiplication, and you should get back to what you originally had. So right there, this top piece, that is in standard form, and then this new piece, it is in factored form, and this is a parenthesis right there. Maybe I can, there, that looks a little better. All right, so that is factoring. Let's go on the next page. Now this one here says to solve. Now, whenever we solve these, let's scroll back up to the top. Number 18, 19, and 20, we solved them. Something common about all three is that they were factored. So on 22, we're going to need to factor and then solve. So for the factoring part, I just ignore the equals 0. He just goes along for the ride. And then I think about what can I pull out? I can pull out a 5 and a y. My first term, I removed the 5, and then I'm left with just a plain old y left over. Right? Think about it as dividing by 5, right? In the second one, I removed a 5, so 10 divided by 5 gives us 2 left over, and the y has been factored out. Again, you can check yourself by trying to distribute back in, and you should get what we started with. Now that we have it factored, we can split it up, and we say, well, we have this piece and this piece, and then we use the zero products property. So 5y is 0, and y plus 2 is 0. So on the left, we get y equals 0. On the right, we get y equals -2. Scrolling down, 23. This one just says to factor. It doesn't say to solve, just factor. So I think about my 8 and my 20. And I think about what is the biggest number that I could pull out of both of them. And I think that number is going to be a 4. So I'll pull out a 4 out of both. Oop, I don't want to just pull out a 4. X's, we could pull out an x squared, right? The first one has 3 of them. The second one has 2. All right, looking at this first piece here. 8 divided by 4 is 2. X cubed divided by x squared is going to be a plain old x. -20 divided by 4 is a -5. And then I removed both of those x's. And there we go. That is our answer. 24 says to solve. So I'm looking and I have the 3, and then in the other piece I have a, well, it's like a 1. Right, I'm not going to pull out anything there, but I could pull out a t from both. So I'm going to factor a t, and I'm going to be left with 3t minus 1 equals 0. Now I use the zero products property. The yellow piece is just t equals 0, and that's it. We can actually box that in right there. That's our answer. Next up is 3t minus 1 equals 0. So 3t is 1. and t is 1/3. And there we go. There are our two answers. All right. Well, that looks like that was section 4. Again, we solved as they were factored, right? To solve these and to solve lots of polynomials in the future, they're going to be equal to 0. That's going to be a big theme that you'll see in the future. And they're going to be factored, okay? And then we had a few problems here like number 21, number 22, 23, and 24, where we had to factor them, okay? Now, 2 of them we didn't have to actually solve, but we did have to factor. And that idea of factoring is going to stick with us for a long time. So make sure that you understand what's happening there. All right, that's all.